Hi everyone, welcome to Analysis and Benefits of GaN and High Frequency Wireless Power Transfer Applications. My name is Paul Wiener and I'm Vice President of Marketing at GaN Systems, and I hope you enjoy this presentation. Imagine, if you will, a world without wires. We're all very familiar with this image on the left. Lots of devices, lots of wires, lots of adapters. And what we really prefer is this image on the right-hand side, where we can just drop and connect charging, whether it's our devices, all the way up to our modes of transportation and everything in between. So let's take a look at what we have today with what I call wireless power transfer 1.0. You can see in this diagram here that there aren't significant differences between wired charging and wireless charging. They look very similar, and in some cases, the wireless charging is more difficult to use than wired. So in summary, not really what we want. Taking a closer look at what we have today, it's certainly not ideal. Alignment issues, power issues, fast charge requirements that aren't being met, and an overall user experience that, quite frankly, is barely mediocre. Additionally, there are lots of technical challenges with the systems we have today. You'll see in these diagrams that there are cautions, warnings, and significant limitations in how it can be used, where it can be used, and, for example, it even interferes with our key fob in the car. Given the limitations of WPT 1.0, I suggest it's time for us to move to 2.0. You can see from this chart, it has a lot of advantages, from spatial freedom, charging power levels, smaller size, higher efficiency, the ability to charge multiple devices at once, very easy to install, high durability, and does not interfere with other metal objects. There are lots of applications that can be used with high frequency wireless power transfer. Here are a sample of the many things we're seeing with customers who are using high frequency wireless power transfer to get the power levels they want, the spatial freedom they want, and the user experience they need. So let me show you some real world examples where customers are using our GaN to change how they think about wireless power. And you can see from this selection that power levels are not a barrier, from 33 watts all the way up to a kilowatt. We've had some customers design systems that are dual mode, so they can do WPT 1.0 and 2.0. You can see in the second example here, the 100-watt through wall, that space and air gaps are not a limitation. This is a design with a 200mm air gap between transmitter and receiver. And that third diagram there with the power tool, you can see it's quite easy to charge multiple devices at once, simultaneously, and at high power. And speaking of high power, you can see 200-watt scooters, 300-watt drones and robots, and even a 700-watt motorbike scooter. So whether it's power levels, air gaps, efficiencies, high frequency is really the way to go. All of those applications are really good examples of how wireless power transfer is being implemented to solve problems. And on this slide, I wanted to show you a little bit more in depth on what it takes and what companies are doing to really make this wireless power transfer useful. So here we have an example of drones and robots being wirelessly powered via Wybotics solution. And what they have done is created a system that can charge 300 watts wirelessly, so you get fast charge. Again, with wireless charging, you can make that drone or robot autonomous, and they've gone above and beyond by getting FCC regulatory approval on their designs, so these drones can be used beyond visual line of sight, an industry first. And coming soon, inside all of our cars, is wireless charging of our devices. Take a look at this video for a vision of what's coming in the future.
Motherson has customizable wireless power solutions for automotive interiors, including advanced Qi, magnetic resonance, and RF technologies. Motherson is partnering with the first FCC-certified magnetic resonance technology, which is capable of powering LEDs, sensors, and multiple devices beyond 15 watts of power, allowing for movement up to approximately 20 centimeters in the Z-plane, including the cup holder, and over the air, without contact. It can also charge multiple devices simultaneously. This is the first system ever developed that can surpass even wall charging power.
As we're discussing how wireless power transfer solves problems, I wanted to show you one example that we're working on with residential access for high-speed data. Some people call it through-wall power and data. And really the challenge here is getting high-speed data from the outside world through walls and windows inside of buildings. And that can be with fiber to the home, 5G fixed wireless access, or satellite internet systems. The common thread in all of these is getting the high-speed data from outside to inside. So to reiterate, the problem statement is getting that data the last 100 feet to the user, indoors. Right now there are several ways to do that: cable, DSL, and fiber to the home. But the mobile phone carriers want part of this action. They've developed fixed wireless access, and now they need that last 100-foot solution to get the data from the pole to the home. So as I mentioned, the challenge is really where to place that customer premise equipment called CPE. When placed outdoors, the mobile operators can serve 2 to 3 times as many households as they could if the unit was inside, where you can see they have requirements of 2 to 3 times as much spectrum needed if the unit is indoors. The challenge with putting the unit CPE indoors is that now it's very expensive to install. Drilling holes through walls, getting permits, getting highly paid technicians to do the work is all a very expensive proposition. Whereas if you're able to install the unit outdoors and wirelessly charge it via indoors, where there are many opportunities to get power outlets throughout the home are quite plentiful, this makes for a much lower cost installation and really gets to that target of a DIY type install. Here's a basic diagram showing how the system works. You can see the outdoor unit receives power from the indoor transmitter. That outdoor unit then has the power to power the electronics to receive the data signal, and then transfer that data signal wirelessly back through the wall to the indoor unit and then to the modem. Here is one of our field trial demonstrators. You can see that it's got a 200 millimeter transmit receive gap We utilized our GaN Systems 100-watt power amplifier. We designed some high mutual coupling coils, and we worked with one of our partners and used one of their wireless data transfer eval kits. I mentioned coil design. There's quite a bit of difference between coil design between small air gap and large air gap. You can see some of the dynamics here in these charts where coils optimized for air gap show quite a big difference in their performance. The result of our design is output power of greater than 60 watts with a nearly 80% end-to-end efficiency and a data throughput rate at nearly 100%. Now that I've showed you all the great things Wireless Power 2.0 can do, let me show you how it gets implemented. Now you've heard me say several times high frequency and may be asking yourself, why high frequency? Well, we need that to achieve the desired user experience. I won't go into all of the math, but the charts on the right show to maximize efficiency, you've got to maximize your figure of merit. Your figure of merit is really maximized by getting the greatest out of your coils measured by Q factor, and that's maximized, as you can see on the lower chart, at high frequency, typically in the 5 to 15 megahertz range. We need to select an ISM band, 6.78 megahertz, and we need a transistor that'll switch effectively at that frequency, which is GaN. So now let's take a look at GaN, where GaN's being used today, and is it a technology that's really viable for this application? And it is. We're seeing GaN being used across many different markets, from consumer travel chargers to solar ESS systems, data center power supplies, and designed into automotive EVs. So a well-accepted technology, proven, reliable, and cost-effective. At GaN Systems, we've got a broad range of transistors, both 650 volts and 100 volts, and many reference designs to help you get started and get your designs done quickly. Here you can see we've got charger and adapter reference designs. We've got a whole line of wireless power amplifiers, and we've got high power PFC and LLC reference designs for high power power supplies. So let's take a look at what that wireless power transfer system looks like. As many of you know, you've got a transmit side and a receive side. Really the key elements to this design are the power amplifier, the transmit and receive coils, and then putting it all together with conformance and regulatory testing. The first segment I'd like to talk about is the power amplifier. At GaN Systems, we've got 4 options here from 50 watts up to 1 kilowatt. Those reference designs can be purchased and downloaded at the URL you see at the bottom of the page. The next area where customers usually have questions are on coil design. Fortunately, AirFuel, who's the organization that runs the Consortium for High Frequency Wireless Power Transfer, has a great tool on their website for coil design. And for those of you who are AirFuel members, there's a complete library of pre-designed coils available to members. And the third area I'd like to talk about with respect to designing the system is conformance testing. I've given again another URL here for AirFuel, where we've got several webinars describing how to prepare for EMF, EMC, and testing the system itself, all available to make sure that it's quick and easy and understandable for the design community. So in summary, wireless power 2.0, it's a desired user experience we want. There are standards in place via the Air Fuel Organization. Design tools are readily available. And we've got a very mature ecosystem. And for GaN systems, again, the technology is being used across many different marketplaces. We've got a broad selection of devices for all of those applications. We've been shipping since 2014, and success in these and many more. So I thank you for your time. If you have any questions, please go to gansystems.com. Thank you.